Assalamu alaikum. My name is Shahriyar, and in today's lecture we will explain some decompositions types of signals. So the first one is impulse decomposition. So what is impulse decomposition? Actually, we can define it as it it is an sampled signal breaks into an component signals. Here each signal contain n samples. So suppose we take this example. Here we have different points or signals. So when we decompose is in impulse decomposition, then by using this bar actually it goes here and all other will be 0, because we know in impulse only its value is at 0, all other are 0. So the second we take this part, which is like this one, and all other will be 0. Third we take like this one, and like here all other will be 0. So this is the impulse decomposition. Now we see some of its advantages. So its important advantage, one of the best, is it is very simple, because it allows to examine one component at a time. So that's why it is very important. So in step decomposition, here also n sampled signal breaks into n signal elements. Suppose we have a signal like this, so we have, suppose it's at 0 its amplitude is 1, and at 1 its amplitude is suppose 2, and at 2 we take its amplitude -1. So when we decompose it, like at first one its amplitude is at 0 is 1, so we take 1 like this one, and so on. And the second component is at 1, which is 2, so we take it as 2, and at 1 there is nothing, but at 1 here is amplitude is 2, and so on. And the last one is at x is equal to 2, which is its amplitude is -1. So -1, 0 this is 0, and 1 this is also 0, and 2 this is -1, and this will be as so on, because this is the step function, so it goes till infinity. So now we see its some advantages. Actually here also each component is step, so it is easy to perform. And here the complexity is reduced, because we examine one signal at a time. So in even odd signal decomposition, it basically decomposes the signal into two parts. The one is even symmetric, and the second one is odd symmetric. So suppose we have a signal x of t. If it satisfies this equation x of minus t, then we say it is a even signal. For example, we take x of t equal to cos t. So when we put x of minus t, then it will become cos of minus t, as called consume negative part, so it will give us cos of t. So we see x of t equal to x of minus t because both has same values. Now we also see its graph, which is like this one. As it is the symmetry about origin, we see right hand side it is the same as in the left hand side, which is the symmetric mirror image. So we say this is a even signal. Also we can say a signal like this one. Suppose this is a direct signal, this is also a even signal because both of sides origin it has same signal, because this is left hand side and this is the right hand side, this is the same value. So in the now we see the odd signal. In odd, if suppose we have x of t equal to minus x of t, then we say this is a odd signal. For example, let's see x of t equal to sine of t. When we apply x of minus t, then sine minus t. We know sine, in sine the negative part will be in outside like this one, and it will become sine of t. So we see these two values are same, so we say this is a odd signal. We also can see its graph, because we know the sine signal is like, its graph is like this one. So it is the inverse at origin. See, this is the inverse part at origin, so this is the odd signal. We can also see some of its advantages. It is used in power series, also can apply in Fourier series and in public transport. There are some its applications. Interlaced decomposition. Actually, interlaced decomposition, it actually increase the speed of system by a factor of 100 or 1000. It is also a very easy method to apply. So our last topic for today's video is alternative to linearity, which means we can convert non-linear signal into a linear signal. Suppose we have a signal u of n, which is equal to the multiplication of two signals b of n and c of n. This is actually, we know, a non-linear signal. But when we apply a logarithmic to signal like a of n and log b of n multiply c of n, then the result we obtain is like log b of n plus log c of n. So our signal will become a linear signal. So this is all for today's lecture.